as a differentiator. So right now today's class I explained how the operational amplifier acts as an integrator. Okay, understand? Right. See here I write the definition of integrator. A circuit that performs an integration of input signals is called an integrator. Is called an integrator. An integrator. Okay. So the output of an integrator is proportional to the area of the input waveforms over the period of time. Okay, so here whatever the output we are collecting, that output is always proportional to area of the input wave, area of the input wave from over the period of time. Okay, so we will derive what is that soon. So this is the actually the integrated meaning, integrators meaning. Generally these type of operational amplifier acts as integrator. We are changing some parameters, like here I am considered, see from uh, this operational amplifier circuit. Once you see this operational amplifier circuit, the inverting terminal, whatever the inverting terminal we are connecting to negative terminal, that inverting terminal we are consider some input voltage is given to this inverting terminal through a resistors R1, and the non-inverting terminal is simply grounded. Non-inverting terminal is simply grounded. See, we are consider a feedback process, but this feedback is connected through a capacitor. Okay, in previous case we are consider feedback through resistor, but in this case we are consider the feedback through the capacitor. Okay, and see here the potential A at terminal A, and this is the potential B at terminal B. So now potential VA at the terminal A and potential VB at the terminal B. So these are two potentials. So according to virtual ground concept, these two potentials are always equal. Okay, now if you consider a small input signal is given to this inverting terminal means, so therefore the current which was traveling along or through this resistor R1 is I1, and at point A the current is splitting in two directions. So one current is entering into the op amp and another current is entering into through a capacitance IC. Okay, so this entering current through op amp is considered as zero because here we are maintaining at high input resistance. So that is the reason this current is not entering. So this current is always zero. The only entering current is considered through a capacitance only. So right now I'll use the Kirchhoff's current law from the above loop. Okay, so according to Kirchhoff law, the entering currents, the sum of the algebraic sum of the entering currents at point A is equal to sum of the algebraic currents living in the point A. So therefore, according to that this concept, so the sum of the entering current is I1 is equal to sum of the living currents is IC. Okay, sum of the entering currents is I1 here. Sum of the living current is IC here. So this IC is the current which was traveling through this capacitor, and the current I1 which was traveling through this resistor R1. Okay, so now I am applying uh, KCL. According to KCL, the sum of the entering currents is equal to sum of the living currents. But we know that already current I is equal to voltage by resistance. So I want to find out voltage by resistance through this resistor and capacitance. So therefore, I am applying this phenomena to this circuit. So therefore, now what is the input voltage? This is the input voltage. Now current direction is this direction. So input voltage VI minus potential at VA divided by R1. So therefore, I1 is nothing but V in divided by R1 minus VA. So potential is V in minus VA. So this is V in minus VA divided by R1 is equal to, here see the how much current is developed across this capacitor. We want to find out voltage, that current. So I already in previous case I explained. See once again, see this process, you know, see The capacitance is nothing but C is equal to Q by V. So therefore Q is equal to CB. Differentiate both sides. Dt by dq by dt is equal to C times of dV by dt. So here dq by dt is nothing but the rate of charge. The rate of charge. Otherwise the charge. See, Q is nothing but charge in the capacitor. Now this charge will be, rate of times will be changed. So the changing charge is always gives current. So this is the capacitor current. Then capacitor current IC is equal to C into dV by C, dV by dt. Okay, so here we are using, this is called voltage across the capacitor. So that's why VC divided by T. So once again I'll write this equation in this case. So therefore now here I am considered C times into dVC divided by dt. So this is the complete equation. We will get this equation by using Kirchhoff's current law. Okay, so please note everybody. I'll move to next page. Okay, see once again, if VC is equal to Vn, how I can conclude that if you using Kirchhoff's voltage law in this direction. Okay, so Kirchhoff voltage law in this direction. So according to Kirchhoff voltage law, see simply this is actually from starts here. Okay, so I want to find out in this loop actually, if E loop, feedback loop. In this feedback loop, what is the potential across this capacitor? The potential across this capacitor is VC here. Okay, and this is the output voltage. So this is positive, this is negative, and this is also positive. Okay, so therefore according to applying Kirchhoff voltage law across this loop, Kirchhoff voltage law, so plus VC plus V naught is equal to 0. So plus VC, from positive to negative, you will move this direction. Okay, this loop. In this loop you are applying Kirchhoff's voltage law. So according to Kirchhoff voltage law, the voltage which was starts from across this capacitor, first of all you want to write the voltage through this capacitor, after then it move to output voltage. So therefore VC plus, because plus and minus, this is starts with plus, that's why plus VC, and this is nothing but V, this is nothing but V naught potential. So finally we write V naught is equal to minus VC. So simply substitute VC in place of VC, you will write minus V naught. So VC is equal to minus V naught. So simply substitute this value in this equation. Okay, so therefore I'll use another page. So please note everybody, I'll move to another page. So therefore once again I write this equation. So what is the value V in? V in minus V naught divided by R1 is equal to C times dVC by dt. So I'll write once again this equation as it is written. But here VC is equal to minus V naught. So I already proved this equation, see in previous class. So this is the equation. This equation is came from applying Kirchhoff's voltage law, KVL law, KVL, Kirchhoff voltage law. I got this equation. Okay. So therefore, I'll simply substitute this equation. So finally, we will get V in minus V naught divided by R1 is equal to minus C times dV naught by dt. So finally I got this equation. Okay, and see, according to virtual ground concept, the potential at B is 0. So therefore, the potential at point A is also equal to 0, because according to virtual ground concept, these two potentials are equal. So whatever the potential is there at terminal B, the same potential will be developed at terminal A. So I once again I apply from virtual ground concept, from virtual ground concept, V at potential A is equal to VB potential A is equal to 0. So using this virtual ground concept, so this equation will be changed, because the potential, sorry, here VA, I'll write mistake here, VA, this is VA. Okay, so from this temperature, this potential is always 0. So finally we will get this equation, V in by R1 is equal to minus C times dV naught by dt. So understand everybody this equation how it is writing here. Okay, so this is the potential. I'll change from using KVL law. After then using virtual ground concept, this potential VA is also 0. So finally we get this equation. Okay, now integrate the above equation both sides. Integrate above equation both sides. Integrate above equation both sides with considering limit, with considering limits 0 to small t. Okay, so therefore I'll write integration with respect to with integration of above equation with respect to temperature, with respect to time, and considering the limits 0 to t. So therefore I'm applying integration, integral 0 to t, integral 0 to t V in divided by R1 is equal to minus C, and C is a constant because it is a capacitant constant. So integral 0 to t dV naught by dt into dt. So this is also into dt. Okay, so finally we will get this equation. But see, differentiate term and integrate will be both are cancelled. So I'll change this equation. This is called 0 to t V in divided by R1 into dt is equal to minus V. So, and d by dt, see, this differentiation d by dt and integration will be cancelled. So this equation will be cancelled. So finally, we'll get only the value V naught. So this is equivalent to, because integration of d by dt into dt will be cancelled. So we will get only V naught. So therefore, V naught is equal to minus 1 by C times integral 0 to t V in divided by R1 into dt. But this R1 is also equivalent resistor, that is also constant. So we will take it outside. V naught is equal to minus 1 by R1 into C integral 0 to t V in dt. So finally this is your answer. Okay. Why? Because see, the output voltage, what are the output voltage? That output voltage is integral times of input voltage. Okay, so this is your final answer. Okay, so please note everybody, this is the form of output voltage of integrator. See, please note everybody, I'll move to next page because we will discuss about wave pattern of this integrator. Please note everybody, Okay, so this is your final answer. Um, I'll move to next page because I draw the wave pattern of this integrators. Next page. So the wave pattern, wave pattern of integrator. So how the wave pattern is there in integrated circuit? See, so first suppose I'm applying some input voltage. See, this is actually input voltage V in, and this is the output voltage V naught, and this is the input pattern V. Okay, so first suppose I am applying here a square wave. Okay, so I'm applying a square wave. Here I am applying a square wave. This is actually square wave. I'm applying square wave as this input. Okay, but what finally they'll get? See, what you will get output voltage. See, if I am applying a input signal as a square waveform, this is a square waveform. This is an input signal, square waveform input signal. Then finally, I get after performing this square signal, we will get rectangular wave. We will get rectangular wave. See, the wave is look like. Okay, so this is actually inverting wave because we are applying input signal as in inverting terminal. So therefore, the output of final waveform is inverting because see, this is actually positive peak, which is represented by positive here. Okay, and see the negative side, the positive side was near cycle. Only they'll consider only negative side. So this is the final square wave. We will get triangle triangle waves as a output. Okay, so we are given input is a square signal, but finally after integrating perform we will get triangle wave. Okay, so our output will become in the form of triangle waves. So this is the wave pattern. Like if you see any type of input signal you will give, that input signal will be almost all change, because after integration what the value. So what is the integration of sine? This is cos. Obviously if you give a sine input signal, you will get, after performing integration, you will get cos line. Okay, cos waveform. Similarly he will give you a tan wave. Okay, so tan wave representation. Then finally you will get tan is nothing but cosecant. So cosecant waveform you will get final after integrating. After the performance of integrating, the wave pattern is almost changed. And if you given input signal is a positive and negative peak like that, but finally you will get a virtual image. Okay, so virtual means it is an inverted image. Inverted graph will be forming outside. So understand. So please note everybody. I'll move to next topic. And this is the last topic of this lesson, that is called comparators. Please note everybody. I'll move to next page for next topic. Actually comparator is a special topic. Maybe today's not we are not having sufficient time to explain comparator. So better today I'll discuss about some problems regarding differentiator and integrator, and also I'll do some problems regarding gain of the amplifiers. Okay, so of tomorrow we will discuss about the comparator circuit diagram. Until then, after then the completion of comparator integral, almost analog electronics will be completed. So we'll move to digital electronics next class. Okay, so please note everybody, I'll move to next page for doing some problems today. After completing the problems, then we will go to integrate the comparator operational amplifier as a comparator. Right. So move to next page. Some problems. I'll discuss about today problems. So first problem. This problem is based on inverting gain. Okay, so problem is an inverting amplifier has, first problem 1, an inverting amplifier has resistance R1 is equal to 10 kilo ohms and RF is equal to 150 kilo ohms. 150 kilo ohms. Okay, find the output voltage. Find the output voltage. Find the output voltage, comma the input resistance, comma the input resistance, and the input current, and the input current, and the input current for an input voltage is for an input voltage is is input voltage of one volt. Okay, so this is your actual what is the problem is given. An inverting amplifier of resistance R1 is given and RF is a feedback resistance. So here the input resistance is given, already feedback resistance also given. What he was asking from this problem is find the output voltage. Okay, so output voltage means it is a gain times of the input voltage, but the input resistance and the input current of the input current for an input voltage of 1 volt. So they are given input voltage is 1 volt. Okay, so right, first of all, solution. Given 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 okay, no problem. Once again recoil. Already completed this problem in previous class, I think somebody told to me. No problem, once again we will write. So given output, given R1 is 10 kilo ohm and RF is equal to 150 kilo ohm. Okay, and voltage, what is the input voltage? Input voltage V in is equal to 1 volt. So simply substitute. What is the gain? Gain V naught is equal to minus RF divided by R1. So this is the inverting amplifier, because inverting gain is gain times of its input voltage V1. So this is your actual formula. So therefore output voltage V naught is equal to minus, what is RF value? 150 kilo ohms. 150 divided by 10 into 1. So therefore we will get 15 minus 15 ohms. So this is the output voltage. And what is the input resistance? Input resistance R1. So it is almost given. Input resistance R1 is approximately equal to R1. So therefore that is 10 kilo. So this is the second bit. Okay, and this is the first bit. He was asking input current also. What is the input current? Input current. So this input current is equal to V1 by R1, and this is 1 by, what is the V1? V1 is a 1 volt and R1 is nothing but 10 kilo ohms, and 10 into 10 power 3. So finally we will get 10 power minus 4 milliamperes. So this is your input current. So please note everybody. I'll move to next problem based on feedback resistance. Please note everybody. I'll move to next topic. So next problem, problem 2. Problem 2. The input to the differentiator circuit, the input to the differentiator, differentiator circuit is a sinusoidal voltage, is a sinusoidal voltage of peak value 5 millivolts. Okay, and the frequency and the frequency 1 kilohertz. Find the output voltage. Find the output voltage. Find the output voltage if R is equal to 100 kilo ohm and C capacitance is equal to 1 microfarad. Okay, so this is actually problem given. The input to the differentiator circuit is a sinusoidal voltage. Input is a sinusoidal voltage of a peak value 5 millivolts and the frequency 1 kilohertz. Find the output voltage if R1 input resistance is given 100 kilo ohms and also capacitance also given, that is called 1 microfarad. So I want to write solution. So here the solution. So first of all, take the data. What are the data is given? Okay. He was told to me in this problem. See, please read this problem carefully. The input to the differentiator circuit is a sinusoidal voltage of peak value 5 millivolts. So this is actually 5 millivolts is the peak value, means amplitude actually. This is a amplitude. Understand? Okay, and similarly frequency is also given, that is called 1 kilohertz frequency. Okay, so first of all you will write what is the output voltage of differentiator amplifier. This is the differentiator because we are already mentioned differentiator. So I want to write the voltage. So simplicity, first of all I'll bypass this screen. Okay, see, is given the output voltage. The output voltage V0 is equal to, see what is the differential formula, V0 is equal to minus C R, okay, into dV0 by dV in by dt. So this is the our differentiator equation formula. Okay, so first of all here I want to find out input voltage because they are not given direct input voltage. They are mentioned it is a sinusoidal voltage of a peak value 5 millivolts and the frequency. So first of all I want to find out what is the input voltage, because this input voltage is given in the form of AC signal, you know, alternate current signal. So therefore first of all I want to find out input voltage. After that we will differentiate input voltage. If you get input voltage, then you will substitute here d by dt times, you will differentiate, you will get final answer. Okay, so V1 is equal to, first suppose I want to find out input voltage. That input voltage is nothing but, he was given peak to peak value means it is a form of AC signal. So they are given sinusoidal voltage of peak value 5. Here 5 milliamperes is nothing but amplitude. Okay, here amplitude is 5 millivolt. Okay, and similarly they are given frequency also. That frequency is 1 kilohertz. So frequency is nothing but formula. What is the frequency? They are given frequency f is equal to 1 kilohertz. Okay, and see what is actually sinusoidal waveform, a sin omega t. Okay, So actually sinusoidal form is A sine omega t, omega t. Okay, but what is the omega? Omega is equal to 2 pi f. Understand? Omega is nothing but 2 pi f. Okay, so this is f. This is 1 kilohertz. Okay, so first of all I'll write the general equation. V1 is equal to A sine omega t. This is the sinusoidal waveform. Okay, so here A is the amplitude, that is already given millivolts. So that is nothing but millivolts. Is it is okay? No problem. Voltage is always in millivolts only. So therefore, almost this is the correct form. But here the kilohertz is given. So this is the omega formula. So A sine omega is nothing but 2 pi into f. Okay. So see here omega is nothing but 2 pi f. Okay, so simply 2 pi f into is the t is there, so into t. Okay, so therefore this is a is given 5 milliamperes and this is a sine and 2 pi. What is the f value? 1 kilohertz is given, but we are consider only hertz. So this 1 kilohertz will be written as, it will be written as 1000 hertz. Okay, 1000 hertz. So therefore this is into 1000 t. Okay, so this is your input voltage actually. So this input voltage is right now we will write this for simplification. So 5 2s are 10. Okay, otherwise you will maintain this 5 2000 and 2005. So this is your final input voltage. So simply substitute this final input voltage into above equation. So finally you can get V naught is equal to minus C. C is already given 100 milliamperes. I'll substitute all these parameters because R is given, C is given. Given R is equal to 100 kilo ohms and C is equal to 1 microfarad. Okay, so see, please simply substitute all these things in this equation. Okay, so minus, what is the C value? C value is given 100. Sorry, what is the R value is given? R value, first of all write R value. R value is 100 kilo ohms, that is minus 100 into 10 power, see kilo 10 power 3 ohms into, what is the C value? C value is 1 microfarad, so that is 1 into 10 power minus 6. Okay, after that d by dt, so this is actually 6 d by dt. What is the input voltage? 5 sine 2005 t. So this is your final expression. So this value is around 0.1 way because it is 10 power 3 and this is a 10 power 5 into 10 power minus 6. Understand? This is a 10 power 5 because 3 plus 2, 10 power 5 into 10 power minus 6. And this is finally we will do this d by dt. Simply 5 is a constant, simply take it constant. Okay, and what is the sine 2 pi by t? This is called cos 2 pi by t because differentiation of sine is cos. So cos, okay, and you will consider sine is a cos 2000 pi, okay, 2005 t into differentiation of inside again 2 pi t, 2000 pi t, that value is nothing but 2000 pi. Okay, so 2000 pi. So finally you will get V naught is equal to, this is a minus, V naught is equal to, this is a 10 power minus 1, so 10 power minus 1 into 2000, so 2000 pi into cos 2000 pi t. Okay, so finally you will get this value is around see, this is 10 power minus 10 is 1 by 10 times 1 by 10 times 110. So finally you will get what is the answer? here 5 is missing, I think. Okay, so here there is a 5 here. Okay, 5 times. Okay, so therefore this is 5 twos are 10, 10,000. Otherwise simply you will take this is 1 by 10 into 5 twos are 10 and this 3,000s. Okay, 5 into cos 2050. So the 100 will be cancelled 1. So therefore finally we will get minus 1000. Okay, so this is minus 1000 pi times cos 2000 by t millivolt. Millivolt. Okay, so this is your final answer. This is your final answer. Understand? So please simply note, everybody. So please note, everybody. So please note, everybody. I'll move to next problem. So the next problem is so next problem. We'll move to next problem. Okay. So problem 3. A 5 millivolts, a 5 millivolt, comma 1 kilohertz sinusoidal signal is applied to input of op amp is applied to input of an op amp integrator for which R1 is equal to 100 kilo ohms and C is equal to 1 microfarad. Find the output voltage. Find the output voltage. Understand? So this is a problem. For simplicity, I'll bypass this screen. See, solution. Okay, so what is the output? This is a actually integrated problem. This is a sinusoidal signal is applied to input of operation amplifier of integrator. So they are clearly mentioned this is an integrator. Okay, so what is the output voltage of this integrator? So the output voltage V naught is equal to 1 divided by R1C. So this is actually minus 1 divided by RC. Okay, integral 0 to T V of T dt. So this is your actual integral formula. But here given data, see R1 is equal to 100 kilo ohms and capacitance is equal to 1 microfarad. Okay, and also given there is an input signal starts with a 5 millivolts. So what is the input signal? Actually, input signal formula V is equal to A sin omega t. A sin omega t. Understand? A sin omega t. And see, if you write this equation, is already A is given 5 milliamperes. Amplitude is equal to 5 millivolt. Okay, and see frequency is equal to 1 kilohertz. 1 kilohertz. So simply you will write this is a 5 sine. What is omega? Omega is nothing but 2 pi f. Okay, 2 pi f. So 2 pi f into times of t. Okay, so therefore you will write this is a 5 sine 2 pi into what is f value is nothing but 1 kilohertz. That is called 10 power 100. Okay, so 10 means 1000 times. This is called into 1000 t. So finally we will get this is 5 sine 2000 pi t. So this is your input signal V input signal. So this is your input signal. So simply I'll highlight this. This is the input signal by input signal. Okay, and they are assumed that T1 is equal to 0 and V1 is equal to 0. For suppose if you consider both the limits also 0 to T limit, or we will get the input voltage. So simply substitute these things into above equation. So finally V0 is equal to minus 1 divided by what is R value? R is nothing but 100 kilo ohms and 10 power 3, 10 into 10 power 3 into 1 into 10 power minus 6 integral 0 to T. What is the V in value? 5 sine 2000 pi t. So this is your answer. You have to integrate this. This value is already we will find out 10 power 4 into 10 power minus 6. So 10 power, this is called 100. 100 means 10 square. Okay, so this is 10 power 5, 10 power 1, 10 power minus 6. That is called 1 by 10. So V0 is equal to minus 1 by, see minus 1 by 10. 1 by 10 into integral 0 to T 5 sine 2000 pi t. Okay, so this is your final answer. So this value is V0 is equal to minus 10 into 5 is a constant, simply take it outside. Okay, 5 is constant. So integral of sine, so integral sine omega t is equal to minus cos omega t divided by omega. So this is actually answer. Okay, so you will write same formula you are apply here. This is called minus cos 2000 pi t divided by 2000, because omega is 2000 pi of integral 0 to t, limits 0 to t. So you will get V0 is equal to minus of minus, this is plus 50 into what is the cos omega t? You substitute cos 2000 t, because pi t, 2000 pi t minus cos 0. Cos 0 is 1. Minus of minus, minus 1. So minus 1 divided by 2000. So this is your final answer. Okay. So simply you will get, you will take outside this value Simply take outside this value. V naught is equal to 50 divided by 2000 pi. 2000 pi into cos 2000 pi t minus 1. Okay. So you'll cancel one and see, I'll cancel this equation. 0 0 cancel. 5 ones are 5. I 5 fours are into quarter. So V naught is equal to 1 divided by 40. 1 divided by it's 40 or 400. So 2000 divided by 100 is 40. 40 times of 40 pi times cos 2000 pi t minus 1. So this is millivolt. So this is your final answer. Okay. So please note everybody. Okay. Today class is over. Tomorrow we will discuss about the comparators topic. Thank you. Thank you very much.